Hello to everyone. Today I'll be discussing the rotational structure of three branch bands. Couple of corrections of my previous class, and there in equation number 2 there was 2v of nu was missing. And while I was discussing that the R branch, that time for the corresponding to delta j is equal to +1, that time I told that it is a P branch. It was not a P branch, it is a R branch. Finally, in the derivation, I did it correctly, but while I was speaking, I mentioned that it is a P branch. It is not a P branch, it was a R branch. These are the two corrections of my previous lecture. So let's discuss about the today's lecture. Now, in that case, if you remember, we have discussed about the P branch and R branch, only two branch. Here we have a three branch of the bands where we are discussing about the Q branch. That depending on the orientation of the what sort of the angular momentum distribution is over there. And sometimes what happens that once you have a electronic state of a molecule in which the electron cloud is not cylindrically symmetric, and it has a component of the angular momentum along the internuclear axis. In these states, the total angular momentum of the molecule is a resultant of the component of the electronic angular momentum along the internuclear axis and the nuclear rotation angular momentum perpendicular to this axis, because it is rotating like the diatomic molecule. But however, it is along this direction, then the angular momentum of the rotation is along this. The resultant of the angular momentum is behaving like a symmetrical top molecules. Behaves like an axially symmetric spinning top molecule. So in this case, the rotational level are slightly shifted by amount which is constant for a given electronic state, and one or more of the initial J level are missing in this case. We'll see that in the Q branch, few lines are missing. When an electronic transition, one of the electronic state belongs to the symmetrical top model, the resulting bands are found to have an additional branch of the lines known as the Q branch besides the R branch and the Q branches. The Q branch has its head very close to the band origin. Also, more than one lines are found to be missing. Once I will be discussing that mathematically, we'll see that how it is happening. So the general expression, what we did in the last class, the general expression will be remaining the same. So this nu is equal to nu naught plus of b nu prime of j prime of j plus of 1 minus b nu double prime of j double prime of j double prime of 1. In equation number 2 in the last class, this is a resultant of my vibration and the electronic. If you remember that this value is v naught is equal to ve plus z prime minus of z double prime. This is the value. So I wrote, I think v of nu of e I wrote. So you just correct that. This was another correction. Now where we know that v nu prime and v nu double prime are the rotational constant for the upper and the lower states. Now, considering that the transition for the electronic state, these are the pi 1 to the sigma 1. Yesterday we have defined this sigma 1 and the sigma 1 for our clarity. Now here we are defining that this for the symmetric axis system. Now this pi, capital pi 1 and the sigma 1. So for the upper electronic state, pi is an electronic angular momentum along the internuclear axis corresponding to this gamma is equal to, this capital lambda is equal to 1. While for the lower state, the sigma is equal to sigma, where this capital lambda is equal to 0. So these are the states of the electronic state, electronic angular momentum along the internuclear axis. We are defining with this lambda is equal to 0 and lambda is equal to 1. For this transition, the selections are delta z is equal to 0 or plus minus 1, but z is equal to 0 and z is equal to 0 does not take place. This line is missing. We'll see that z0 and z0 are missing. We'll see that why it is happening now. So one line is missing. So the rotational level corresponding to this 1. So it means that the j is upper level and j is equal to 0. This j is equal to 1 is missing. In that case, what I am representing that now for the -1. Now this j prime is equal to 1, 2, 3 and so on. While for the state, for this pi state, for the sigma state, we have this z double prime is equal to 0, 1, 2, 3 and so on. So in the upper state, in the symmetrical distribution of the angular momentum, which is axially symmetric. Now in that case, the j value of j prime is equal to 0 is missing. Then we will see that the two lines are missing in that case. So the transitions are represented in this case. Now if you look at this 0 to 0, this is just a nu naught, that is the bend origin. Then apart from it, you have this transition. This is a Q branch. This Q1, 2, 3 and so on. The transition, this Q1 is this one. 1 to 1, 2 to 2, 3 to 3 and 4 to 4. Now we'll see that, as I said that, these lines are, the bend head is forming at the origin itself. We'll see that. And if you are moving that apart, then the separation is increasing. Here this separation is decreasing again, that depending on the value of this B nu prime and B nu double prime. On the other hand, for the R branch, they are merging, they are forming a head. So now the transitions for the delta z is equal to plus minus 1, this R branch and the P branch are, while for the additional this delta z is equal to 0, you have a Q branch now. For the R branch now, the delta z is equal to j, delta for the R branch now, R branch, delta z is equal to plus 1. This means that j prime is equal to j double prime plus of 1, and the same derivation now. So now finally, once you will be putting these values, then you have similar relation, you will be getting that. Not 2b of nu prime plus 3b of nu prime minus b nu double prime of z double prime plus b nu minus of b nu double prime of z prime double square. Equation number 2, where this z double prime is equal to 0, 1, 2, 3 and so on. So corresponding to that, what I am getting that is r of 0, r of 1, r of 2 and so on. These are the lines we have shown. If this quantity is negative, the spacing between the lines of the branch decreasing. If this is positive, now it is a negative. If it is a negative, then it is a decreasing. Then you have it is decreasing with increasing the z double prime, and the head is formed, and this head is formed. Now we'll see that how this head is formed. Now for the P branch now. For the P branch, the similar equation we will be getting that. This minus 1 now for the P branch. For the P branch, then simply this nu of P is equal to V naught plus of V of nu prime, Z double prime minus of Z, and Z double prime minus B of nu double prime, Z double prime of Z double prime plus of 1. And finally, you have nu of P is equal to nu naught minus B of nu minus B of nu double prime prime Z double prime plus B of nu prime minus B nu double prime of Z double prime square. Equation number 3. So now in this relation, now what I am saying that this is my negative 1. If it is a negative 1, then this separation will be decreasing. Now as the Z double prime is increasing, then the separation is increasing. So this is band degradation. It is not a head formation. So corresponding to that, now I have the value of Z double prime is equal to 2, 3, 4, giving the line at P of 2, P of 3 and P of 4. These are the lines. The reason is that J prime is missing, J prime 1 is missing. So the transition is possible only this 1 to 2. Means you have the 0 to 1 is missing because J is equal to 0 is missing over here. Then this transition cannot be taking place. Then you have only this one. Then already we have in the P branch, we have in the previous class P1, 2, 3 and so on. The P0 is also missing. So J double prime cannot be 1 because the label J prime is equal to 0. J double prime cannot be 1 because J single prime 0 is missing. This is the case. That is why we have these lines, this P2, P3, P4 and so on. So besides this P0, the line P1 is also missing in this case. Now the final one is Q branch now. In a Q branch, delta J is equal to 0 means V nu of Q is equal to how much? You need to put that as J prime is equal to J double prime. Simply, that is nu naught plus of V nu prime J double prime of J double prime plus 1 minus B nu double prime of J double prime of J double prime of 1, or simply I could write J nu plus of B of nu minus B of nu double prime of J double prime plus B of nu minus B nu double prime of double prime square, or I could write this nu naught plus of B nu naught V nu prime B nu double prime of J double prime of J double prime plus of 1 VQ. So now this quantity we are saying that it is a negative one. If it is a negative, what will happen that these lines spacing is decreasing as J is increasing. So I have shown that these separations is increasing in this one. So it is a red degraded. So the head is forming very near to my origin, the band origin. However, if it is a positive, then this forming in the blue side. The separation is increasing in other side. So the head is. So this now this double corresponding to J double prime is equal to 1, 2, 3 and so on. We have this Q1, Q2 and Q3 and so on. If this B nu prime minus V nu double prime is negative, the branch spreads towards a decreasing wave number, and the line spacing is increasing with increasing J double prime. That is, the branch is degraded towards the red, as we have shown in the figure. And if V nu prime minus B nu double prime is a positive, the branch would be degraded towards the violet. So we know that the R and the P branches can be represented with the common parabola. Common parabola, we have already defined this nu of R of P is equal to nu naught plus B nu prime minus B nu double prime, plus of M plus B nu prime minus B nu double prime of M square, where M is equal to J double prime plus 1 for the R branch, M is equal to minus J double prime for the P branch. So corresponding to Q branch, nu of Q is equal to nu naught plus of B nu minus B nu double prime of J double prime plus 1, where this M is equal to J double prime. So these are the two equations for the RP branch and another Q branch. For that we have this M is equal to J prime plus of 1, and for this P branch M is equal to minus J double prime, and nu of Q is equal to M is equal to J double prime. So now we will see that how this head formation is becoming. In a similar fashion we will see that comparison of these two equations shows that the portrait parabola for a Q branch would be different from that of the R and the P branches. Since, however, the term in M square is same in both the quantities, the vertices of the Q parabola and RP parabola point at the same direction. So simply, if I will plot nu, we have this M 4, 8, 12, 16, minus 4, 8, 12 and so on. So we have, because I am taking the negative one, then you have simply this nu naught. So you have separation is increasing where it is a minimum one. Then this is head is forming somewhere here. somewhere here head is forming initially, then merging, then it is going back. This is R of P. Now in the case of the Q, it is originating from here, so it is red degraded because this V nu prime minus V nu double prime, I am taking it as a negative, then it will be degrading in this fashion. So we have very near, then this is Q. So now this, however, the term of M square is common with both the one. If V nu and V nu naught are not very different, the Q parabola intersecting the new axis almost a right angle. So if this is not very large quantity, as nu is increasing, it will be almost cutting this axis with a perpendicular direction. This means that the head is formed at the beginning of the Q branch. It means that once you have this perpendicular this fashion, it means that it is forming a head at exactly the bend origin. The bend having the Q branch vary after two heads either in the P and branches are shown in the Q branches. So the head of this is entirely different in the PR. So in this branch, this PR branch, the head is forming here. However, in the case of the Q, the head is forming at the bend origin. So one can find out the value of Z for the Q parabola where exactly this head is forming. We can find out with the help of this relation. What we have this relation, this VQ is equal to this one. So what we need to do, d of nu of Q divided by d of Z double prime is equal to that B of nu prime and B nu double prime plus of 2 B nu minus B nu double prime of Z double prime is equal to 0. From here you have this Z double prime is equal to minus half. For the value of Z double prime is equal to half, because this is equal to quantity, it's cancelling out, and you are taking this minus 1, then 1 upon 2. For the value of Z double prime is equal to 0, means the Q branch making the head for that one. Means the value of the Z double prime is equal to 1 upon 2. Whatever the values of V nu and V nu double prime, or the head, the vertex for this Q is happening at this J double prime is equal to minus half. So simply I could write this nu Q of this head is equal to nu naught. In place of that J double prime you have minus 1 upon 2, minus 1 upon 2 of minus 1, minus this J plus of 1, this is 1 upon 2, minus 1 upon 2 plus of 1, then this is 1 upon 2, then minus 1 upon 2, minus 1 upon 4 of B nu prime minus of V nu double prime. So the head is forming for this case, and for the case of the RP is remaining the same what we did in the last class. For the Q branch we have the head formation is this one, corresponding to the J double prime is equal to minus half. So now this is the rotational structure of the 3 branch bands, where this Q also appearing due to that the angular momentum, symmetry of the angular momentum towards the internuclear axis. So now, this is all about this. So far we have discussed the vibrational electronic spectra, fine rotational structure of electronic band, then the rotational structure of the 3 branch bands. Now tomorrow or on Monday, tomorrow is Sunday, on Monday we'll be discussing that the observed intensity distribution, that is a vibrational band system, Frank-Condon principle. So that we'll be discussing. It's a quantum mechanical explanation as well. Then we'll see that 2, 3 or the couple of classes are required, and then hopefully in the next week I will be completing your whole syllabus. Thank you.